Hi, my name is Richard Barry. I work for AWS IoT. I'm best known as the original author of FreeRTOS, and my presentation is about refactoring FreeRTOS for the next 20 years. So about 20 years ago, after researching different operating systems for a project I was working on, because I thought it would be fun, because I'm a geek, I thought I would write one myself. That project became FreeRTOS. Little did I know at the time it was going to consume the rest of, the next 20 years of my life up till now and hopefully in the future. I now work for AWS IoT, that's Amazon Web Services, Internet of Things. Still very much involved in FreeRTOS as it is part of AWS's kind of edge to cloud software continuum. Today, I will talk a little bit about Amazon's involvement in FreeRTOS and also how we very consciously try and keep an air gap between the generic FreeRTOS product, which is not tied to anything, actually, as you'll hear in this talk, especially not specifically any cloud service, and the software which is Amazon specific. Today, we are going to look at the roadmap for FreeRTOS, starting with some of the milestones in the past. We look at the past because it gives me an opportunity to talk about the rationale for the various different milestones, and then we can extrapolate those forwards. And also talk about how that has, how the kind of design and distribution philosophy for FreeRTOS has come about. We'll then look at how we are applying that philosophy to features that are being developed right now, before looking at the next version of FreeRTOS, which is pretty well determined already, and our intentions for FreeRTOS version 12. We're on version 10 at the moment. So real-time operating systems, or RTOSs, come in various different sizes. You can think of very rich operating systems like Linux and QNX, VxWorks, that kind of thing. FreeRTOS is at the opposite end. It's deliberately small. You can think of it really as a library that implements multi-threading. Very focused on the small end, although it does get used on 8, 16, 32, 64-bit, but the ESP32 kind of category of microprocessor is its sweet spot. Okay, so the first milestone to talk about is actually when FreeRTOS was put into a public repository, a publicly accessible repository. When we started FreeRTOS, we were really designing on or implementing ports for very small devices. It's very good for learning how to do it, but those devices were too constrained to really warrant an operating system. They couldn't run an application which was complex enough to warrant multi-threading. When we started porting to 32-bit architectures, then that changed, and FreeRTOS became useful in commercial products and started to take off. When it got to about 2,000 downloads a month, we moved it into SourceForge. It was getting too expensive to host it ourselves. So SourceForge, in SVN in SourceForge, actually. So this predates Git, it predates GitHub. SourceForge serves extremely well. The data you can see on the screen here, the number of downloads a month over the years, that comes directly from SourceForge. You can just go and have a look at that. So really the driver for this milestone was that technology fit. It was the 32-bit architectures were the sweet spot for a very small real-time scheduler, if you think of it that way. The real-time part means that it kind of classifies the scheduling algorithm. It means that there's a deterministic amount of time between an event occurring in the environment and that event being processed. I'm also showing here the code structure that we put into SVN originally. Here we have the source code for the kernel. Then we had a whole load of demos as well. I think at its peak, there were something like 40 architectures and 18 compilers. Some of those architectures are obsolete now, so there's slightly fewer. Just for a laugh, I thought I'd show what the web page looked like in 2004. This is what the internet looked like then. I drew that logo, so I'm not very proud of that. Interestingly, that entire website was generated using Doxygen, just from Doxygen comments in the C and header files. So the next milestone of interest is the release of OpenRTOS, which is a commercially licensed version of FreeRTOS. Why would we do that? Well, FreeRTOS is open source, but some companies just require a commercial license for whatever internal procedural reasons they have. Now, at the time, I was working with Wittgenstein, working for Wittgenstein High Integrity Systems on the safety critical version, which is SafeRTOS. So whilst my company wasn't really set up to do commercial licensing, Wittgenstein had the expertise in the code, so we licensed Wittgenstein to be able to sell FreeRTOS code, but under a commercial license. Moving on then to 2013, this milestone is really driven by, as you can expect in open source projects, kind of removing pain points. This was not only pain points for our users, but also pain points for us trying to support those users. We're very proud of the level of support we can give. And what we were finding was that FreeRTOS was getting integrated with lots of different libraries, and people were coming for support with third-party code integrated with a third-party code with a third-party integration plus their source code. And of course, if anything goes wrong in that bundle of source code, they blame the operating system. What else could it possibly be? It wasn't very satisfactory for them, wasn't very satisfactory for us. So by adding in additional libraries, we were removing those pain points from our user base, because the support team were also able to provide a much better level of support. Very significant here then is, 2016. This is where AWS started to take stewardship of FreeRTOS. May not be immediately obvious why, but when you consider that Amazon Web Services Internet of Things, which is what AWS IoT stands for, there are IoT-specific services in AWS, and there are millions of devices that run FreeRTOS that connect to those IoT-specific services. So Amazon are very motivated to make sure that those devices can connect as quickly and securely as possible. This was really driven by market trends on the FreeRTOS side. So this is the driver for this change, if you like. And to do with scalability, IoT requires a lot more software, as we will come on to see. And this extra investment enables the software to be created. Like I say, I will talk a little bit later about how we air gap what's Amazon specific and what isn't, because FreeRTOS is kind of cloud neutral of anything actually product, despite what you might read about the place. So we were very comfortable working with Amazon, because Amazon are also motivated to make sure that we maintain the philosophy of running on the latest hardware, and making sure that we are providing examples for whatever contemporary projects people are working on. Now, one of the first things that Amazon did was massively simplify the license. They're adding benefits straight away. We had, they changed it to an MIT license, which is extremely well known. It's only 10 lines long. Once you compile your code, the old license and the MIT give you basically the same rights anyway, but the old license was like 1,000 lines or something. So it's a huge benefit just to change to something that people know and is very short. Other things that you may not be aware of that Amazon are doing, which adds huge benefits to the entire community, with open source MIT licensed code. So there's no tie-in. You don't have to be an Amazon customer, of course. So the whole community now benefits from Amazon's security experts. So things like pen testing, AppSec reviews. Something we're excited about is the memory safety proofs that are performed on the code. We lean on Amazon's engineering a lot to provide all those things, and then just open source it. Of course, Amazon are motivated themselves to make sure these things are done, but everybody wins. More visible is the long-term support. So there's like 2 years for free. And then if you want to extend that obviously costs Amazon money to go beyond 2 years. You can extend it to a full 12 years, but that part is commercial. Okay, so the next milestone here also gives me an opportunity to talk a little bit about how our design and distribution philosophy has changed or evolved over the time. And this change is really driven by just the huge diversity that software, like diversity of, let me think, all the different technologies that we have to support. So I think there's, like I say, at one point there was 18 compilers. Some of them are obsolete now. There's all the different architectures that are supported, something like 40 odd at one point. Again, some of those are obsolete. There's is your project a brand new project? Are you adding code to a different project? What's your directory structure? What's your workflow? All of these different variables. So the way that we decided was the most useful for people was to adopt a policy of what we call being deliberately unopinionated. We're not going to offer any opinion or constraint in how you can use the software in your product. That will make a little bit more sense when we come on to the next few slides. So one of the things we did, as I say here on the first yellow point, is moving to Git. And well, it's in Git already, but moving to Git, probably very belatedly, admittedly, as the primary development source, where we were actually working on the code. So we kind of looked at this directory structure before. Now, this is what we call the classic FreeRTOS distribution. Now there are additional libraries in there, but this is still where the kernel is. Oh, let's see, probably, let's do this. This is where the libraries are. This is where the kernel is. So we moved the kernel into its own repository, as we did for all of these other libraries as well. So what does this do to our statistics? Well, you can see there's a bit of an elbow here. Yellow is the statistics coming from Git. There's a different gradient there because we're measuring something else. What we're not sure about yet is this huge spike of noise here. Is this just going to be normal now? Until we've got more data, we're really not going to know. So what does this look like in Git? What I'm showing here is the FreeRTOS organization in GitHub. Each of these pale blue boxes are individual libraries within Git. They're deliberately small, deliberately simple, and don't have any dependencies other than a few functions in the standard C library. We still have a repository which has the classic distribution, but now what these dotted lines are supposed to show is those libraries are submoduled into that. Now, there's nothing here which is AWS specific, right? These are just standard protocols. So how do we, this is how we keep that very clear delineation between generic FreeRTOS code available for everything and the AWS specific parts. So AWS IoT specific services include things like the job service and the shadow. So we also have helper functions for those. These are, or they're stored in a very same philosophy that each is in its own library. Each is in its own Git repository. We also have another package which is similar to the classic FreeRTOS distribution, but this is RTOS agnostic and actually tested on Linux. So this is, there's a very clear delineation here between FreeRTOS and anything which is Amazon specific. So despite what you read, that we do really try and focus on making sure that's the case. So I was going to talk about some of these use cases, but it's easier just to show some real world projects. So what does this distribution philosophy get us? Well, we have what we call the IoT reference integrations, featured integrations. These provide everything you need for mutually authenticated TLS connections, whatever you are connecting to. They also demonstrate over-the-air updates, over OTA, and they demonstrate how to securely store secrets like private keys. So I'm going to go through different ways in which being unopinionated helps. The first is a screenshot from GitHub. If you're familiar with the way they have submodules, you'll notice that all of these libraries are being brought into this project using Git submodules. So you can, in your project, keep that connection to Git. whether it's to the main line so you can bring in the latest patches or the latest updates, or whether you're fixing on a long-term support version and you just want to bring in or see what the security updates are so that you can decide whether to bring them in or not. Note also, whilst I'm here, the number of libraries. I'll come back to that later. On the right, we are showing how being unopinionated enabled a partner to bring FreeRTOS libraries into a project that already existed. Not only that, but also not to change the directory structure either on the disk or in the project, so that it stayed in a way that their customers were familiar with. This is another way of bringing in the libraries. This is using Package Manager, which is web hosted. And here we are using a shell script and a command line within the kind of make files to bring the libraries in. And more familiar to this audience, with much more kind of sophisticated package managers, which is what I'd classify kind of the ESP IDF as. So FreeRTOS is in here as well. And incidentally, although we have lots of demos in the Git repo, you won't find many, if any, ESP32 demos, because the ESP IDF does that for you, creates the projects in a much more sophisticated way and allows you to configure them and make sure they build and all that kind of thing. So for ESP32, this is probably the best way of obtaining the code. Okay then, so last kind of milestone is IoT Express Link, right at the end of our timeline here. So to demonstrate the benefit of this, what I've shown here is kind of the user's view of one of those reference integrations, or it might be their own application code. Now remember I said we've got all those libraries which are required. TCP, TLS, MQTT, which is the protocol which is often used in IoT applications, HTTP clients, all of those different things are bundled in this diagram in this middleware libraries. And we try and make it as easy to use as possible by providing very simple APIs, which or encapsulating some of that functionality in what we call agents. Think of these as daemon tasks, daemon threads. So there's one for MQTT, which manages all the thread safety for you. The kind of core MQTT implementation is deliberately very small, doesn't have thread safety, but you can use it on an 8-bit device. If you're using it in a 32-bit, more sophisticated application, then this will handle the thread safety in multiple tasks, accessing multiple servers. Also, we have another agent for over-the-air updates. So this will download updates for you in the background and just tell you when there's one available that's been authenticated. I pick on these two deliberately because we'll come back to those as well. Here is a very common way of using these libraries. Here we have a microcontroller on which we are running all of this code. It's connected to a radio, and that radio gives the application access to whatever it is you're connecting to. Here I'm showing AWS IoT. So although we try and make these agents as easy to use as possible, it's still a technical product, right? You still have to be able to bring the C libraries in, build them, know how to configure them, get the kind of sequence of execution within your execution flow. So this is the scenario without ExpressLink. And if you watch on the next slide, what we do is move a lot of this or all of this middleware code over onto the radio itself to make what I kind of describe as a cloud modem. So now you don't have to do all those things with the C files like building and configuring. That's all done for you. It does the OTA for you, the update of the ExpressLink module itself and the application. It does the secure storage. You don't have to create a socket and a TLS context and connect to your server. It does all that for you. All you have to do now is write a string to the serial port, and that string is just AT connect to actually connect. So all of that complexity is completely abstracted away. You may even be able to use a smaller processor over here, one with less RAM. Now, AWS only have the spec and the tests and reference integrations. We don't make these modules. These are made by partners, and I've got the URL down here to Espressive's ExpressLink module. Okay, so how are we applying what I've just spoken about to the roadmap moving forwards? I'm going to talk about everything on this timeline. There's no scale on this timeline deliberately because it's not absolute. We may even change the order in which these things come out. I'm going to start by talking about the things that have their labels under the line here, which are things which are being developed right now. So the first is generalizing the OTA agent. Now, when I showed this slide, which I've got in an inset here, you may have noticed that OTA was over on the AWS side. This is quite opinionated because it is connecting to the AWS IoT OTA service. So in the spirit of making things more applicable and less opinionated, this is being kind of broken apart now. So at the moment, you can do downloads over an MQTT streaming service or HTTP. If you've got your own over-the-air update mechanism, breaking it apart allows you to use that instead. You can do things like change when it looks for a download. At the moment, you just get notified when there is a new download available. Maybe you only want to do that at 2 in the morning, whatever. So making it less opinionated, which is one of the pros I've listed over here, more widely applicable. But one of the pros and cons is it's more flexible, right? It's more granular, more Git repos, perhaps with just the streaming, the individual streaming or download mechanisms in them. We will, of course, provide integrations which you can use. You probably have to put it together yourself if you wanted to actually change its behavior. Next is simplifying the MQTT agent. So incidentally, both the last slide I was showing and this one kind of demonstrate the tensions between different good intentions, if you like, in that making something less opinionated also can make it, kind of pains me to say, a little harder to use, but I suppose that's the truth. And with that, that's why I said more flexible is both a pro and a con. Here, we're looking at the MQTT agent update. This is the kind of contradiction between making it completely agnostic of the underlying operating system and the additional burden you put on the application writer, because if it's in its own agent task or thread, then naturally it's using some operating system functionality, and the application writer with this generic one has to kind of provide that themselves. So that's good from an unopinionated point of view, but we also want to make it easier to use. So we are creating a FreeRTOS specific version, and a lot of that additional code then moves inside the agent itself. And you have the choice then of which one you want to use. So I don't want to get too far into the weeds or too low-level detail here, but it doesn't matter if you don't understand this. But when this is showing the MQTT publish function, now if you pass in a callback function, then the application has to write that callback function, call the publish API. The API will return, and that the server, depending on the quality of service you ask for, will then send back an acknowledgement, call the callback, and the application has to handle it. If you leave the callback as null, then all of that kind of signaling is handled completely inside. The application doesn't have to provide any kind of glue code at all. So yeah, pros here, there's less application code, and we've done this without changing the API. So no matter which version you use, the API is the same. And the con is, the contradiction here, if you like, is this particular version of the MQTT agent does have a dependency on FreeRTOS. So other things that are ongoing, this also gives me an opportunity to talk about how we use Git. When we want to change something in the core code, what we do is clone the Git repo, make the change in our personal repo, and then have a pull request to bring it back in. The pros of that are it keeps everything very clean in the core, the primary Git repo. The con of it is you've got to kind of follow the follow the clones to see where the work is actually being done. So if you see a branch in the main repo, that's a very good indication that that branch contains a major feature enhancement that is intended to be merged into the main line. So here we're talking about the TCP stack. IPv4 and IPv6 code bases were different. IPv4 got all the love, and what we've done is refactored that a little bit and merged in the IPv6 code, because this is becoming more and more important, especially with things like the Matter protocol. And that, I think, it may even be merged now actually into the main line. We were waiting until all the security stuff had finished, and security reviews had finished, and also that the protocol testing had finished. I think last time I looked, it was on release candidate 3 or 4. We've also introduced a kind of enhanced or new port, depending on how you look at it, which enables us to hopefully improve or upgrade the security certification. So CSIP is the security evaluation standard for IoT. And currently FreeRTOS has a level 2 certification. And our hope, our intention is to raise that to level 3. So very important to this audience next is the symmetric multiprocessing, or SMP. What we've done here, again, by the way, this is a screenshot from Git, and it's on a branch. So again, this is a major feature enhancement. So this will become FreeRTOS 11. And what we've done is taken symmetric multiprocessing forks of FreeRTOS from various different partners, consolidated them, and then we will merge that into the main line. So we've checked that it doesn't impact negatively those who are just using a single core as far as code size or runtime goes. Espressif have been a fantastic partner here, some major contributions, and I'll have to kind of hold my hand up here. This should have been merged into the main line already. The reason it hasn't was because I asked the team to get the security certification finished first, because changing a major version number partway through that can be problematic, and I think that kind of getting that done cleanly benefits everybody. But as soon as that's finished, then this will get merged in. Espressif again are a little bit ahead of this version here. I think the IDF version has more fine-grained locking for more performant and that kind of thing. But very soon these will all be one, and then we will be able to keep up and support in a much more active way. Right. So what is beyond that SMP FreeRTOS version 11? So this is kind of wrapping up here. We've looked at various different reasons that the FreeRTOS code base has evolved, and the kind of distribution methods have evolved over time. There's nothing here which is going to be surprising, right, for an open source project. It's what are the market trends, what are the pain points, etc. So when we come on to our intentions for version 12, this is future looking now. So that's why I say this is our intention. We've not done it yet, of course. So this is also tackling a pain point for people, and it may not be that pain point is directly applicable to a smaller subset of people. So hopefully I'll explain why this actually benefits the entire community rather than that smaller subset. And that is people who are taking FreeRTOS into developments that require some kind of safety certification. This includes teams inside Amazon, by the way, as well. So what we are going to do, or hoping to do, or intending to do, is make that much simpler. To do that, what we are going to do is, or intending to do, I should say, is remove a lot of the legacy code. So we've maintained backwards compatibility for 20 years. That means there's more than one way of doing things. That makes doing formal certifications much harder. So removing the legacy code, redesigning a few bits, but it's predominantly a refactoring. It's going to create a smaller, leaner code base. This is, I always say, the kind of forewarning that if and when we do this, We will break some of the backwards compatibility because there's only going to be one way of doing everything. I'm giving, always say, this hasn't started yet, so you can have your opinions on this now. And the reason I say this benefits everybody is because, like I say, it'll be a clean start that we can then evolve for the next 20 years after this happens. So that's hence the title of the course. Sorry, the title of the presentation here. So with that, I'm going to invite everybody to get involved. I'm especially interested in your ideas for version 12. If you have safety projects which you are not able to talk about in like the public forum, which I've got the URL for on the screen here, then do feel free to get in touch with me directly. We do prefer to keep everything out in the open, but like I say, I do understand that some of these developments are you may not be able to, you may be constrained from talking about that. Any other opinions on anything else? Use cases, wishes? In fact, wishes you can have in GitHub, like kind of feature requests. You may also notice that we are working to improve transparency in GitHub. The roadmap will get published there as well. At least I should say our intention is to publish the roadmap there as well. So some of the processes and practices are kind of being made more transparent there. And that is it. I hope that was useful for you. Thank you very much.